nature of general solution of a system of non-linear homogeneous equations. This is taken time, and Dr. Pawan Gupta here, Assistant Professor, Department of Mathematics, PNG Government Postgraduate College, Ramnagar. So this is a slide presenting about the general solution of a linear non-homogeneous equation, and how we can express that exactly. So it can be expressed as the sum of general solution of corresponding homogeneous equation and a particular solution of a non-homogeneous equation. What it is standing to means whenever we are going to find the solution of a linear non-homogeneous equation, we have to pay attention on homogeneous equation. There is a homogeneous, of course there is homogeneous part of the equation. Whenever we are having non-homogeneous equations, we are concentrating on the homogeneous part first and then coming to non-homogeneous equations. This can be expressed in the following slides. First, come to the definition. A non-homogeneous system has a form as we can see that this Ax is equal to B. So there is a B which is not 0. Has it been 0, so it would have become a homogeneous equation. A is a K cross L matrix and X is L cross 1. The order is important here, K cross L and L cross 1. So finally L is going to materialize with L, and finally it is becoming K cross 1 for the B. And this is for the B. B is important, that's why the B I am using the phrase, because this is not 0. As we can see, consider the system, and here is example, and here B is not equal to 0, the very character which is making it non-homogeneous. If we navigate to next slide, equivalent system in row echelon form. What is row echelon form? That is understood means where the coefficient matrix is in row echelon form. REF abbreviation is used. So existence of solution. We must just understand the meaning of existence of solution, because unlike homogeneous system, they are guaranteed to always have at least one solution. Homogeneous means everything is 0 on the right hand side. This BR is 0, solution is guaranteed. But if this BR is not 0, then solutions are not guaranteed. So first we have to check whenever we are talking about the general solution of non-homogeneous equations, though they are linear, but still we have to navigate about their solutions, the possibilities, and the navigation for the possibilities, whether it's possible to find a solution or not. So it has a meaning that a basic and non-basic variables. So before we go to the basic and non-basic variable, first we must understand that when there is a row which is 0 in Rx, a row is 0, but this right hand side is not 0, it means zeros are going to be compared with non-zero. So that will be that would be not a contradiction, but sometimes not an identity, and it may provide an insight that we are not going to search for a solution. Means zeros are compared to be zeros. So if any row is 0 and the right hand side is non-zero, so that would create a confusion. It means 0 is equal to 1 for the example. So if this condition persists, then we will have no solution. So we have to check whether we have a solution or not. So best way to find that there is a solution, that if any row is 0, the corresponding bj's they are not equal to 0, then we can go further. Then the solution, then the system has no solution, means 0 is compared to be non-zero. If bj they are not 0, then the system has no solution. If there are no such rows, then the system has at least one solution. So we just keep in our mind that we have at least one solution. So if we have a solution, we can proceed further for that. First, we have to make clear about the concept of basic and non-basic variables. So, in a row echelon form matrix, what is a row echelon form matrix? Where the solution are same. Here we have to pay attention that what happens in the case of equation if we add two equation, if we add the multiple of a equation with any other, so this doesn't alter the solution remains same. And these are the ways just to simplify the complication, and simply the process of simplification of complication, this is vital whenever we are going to understand solution of the matrices. There is example, consider this 3 cos 3. This is already REF matrix. So first and third columns are basic. Just see the first column and the third column. First and third columns are basic, while the second one is non-basic. So how to define the basic and the non-basic columns? Just see, if we talk about the basic column, here we are saying that the first, so pay attention to the first column, the basic column, because two non-zero entities here, and below it all are zeros, and on the left of it all are zeros, because no elements are found here on the left side, so we assume that it is 0. So this is basic. Same is happening with the third column. See, at the third column there is a 1, and on the left side 0 0, and beneath it 0. So first and the third column, how it is going to define means a non-zero element is captured, and it has to be diagnosed whether beneath it, below it, all are zeros or not. So we can see 0 and 0, and on the left side no elements means 0. If we consider about 2, on the left side there is 2, so this doesn't get qualified. And if we think about the third column, there is 0, but beneath it 1, this 1, the left side 0 0, and beneath it again a 0. So first and the third column identifies as non-basic. Particular solution, and this particular solution is important, and it derives its meaning from this word, that the particular. What is particular? Particular solution is that the solution is particular, that is not the general solution. There is a difference between general and a particular solution. So particular means this is specific. Specific when we assign some value to a variable. When the system has a solution, we can assign arbitrary choosing. So arbitrary choosing values to a non-basic variable. In the previous slide, we have identified the basic and non-basic variables. Now we are talking about that when the system has a solution, we can assign arbitrary chosen. Arbitrarily chosen means, and then back substitution algorithm we are going to apply. This example, it would make the meaning clear, that Rx is equal to Br, means R, X variable, R is a matrix, and Br is the solution. Obviously a non-homogeneous equation. When I was given previously example means that matrix. If we talk about the previous example, R is here. R has to define this way. Here R is clear, X is clear, Br is clear, and Br is 2 1 0, and X we are dealing with 3 variables, x1, x2, x3. So what is going to happen? Let's see next. Third row of R is 0. We need to check the third entry of Br. This is all about taking basic and non-basic. So if we proceed in this manner, this is 0, so the system has a solution. First we have to check whether it has a solution or not. So we can see that since the third row of R is 0, if we are going back to previous slide, third row is 0, and third Br, it is 0. So the system has a solution. Had it been non-zero, complication would have been arose, but here because it is 0, so the system has a solution. So we are going to explore in this manner. The variable x2 is non-basic and we can assign an arbitrary value to it. Means whenever we are trying to find a particular solution, the particular is based on the particular value we are assigning to a variable. Here the variable is x2 and we have assigned x2 is equal to 0. This is an important point. We should notice that x2 is equal to 0. So now the particular solution is coming out when x2 is equal to 0. Had we chosen x2 is equal to 1, the particular solution will divert. But here x2 is equal to 0, so the particular solution is based on an assumption that x2 is equal to 0. Now back substitution algorithm means putting x2 is equal to 0 and finding values of other variables, like we are getting x3 is equal to 1, and after that the equation is emerging like 2x1 plus 2x2 is equal to 2, or x1 is equal to 1, and we have got the particular solution, and the particular solution is 1 0 1. Three variables are getting these values 1 0 and 1 in the form of a row matrix. Associated homogeneous system, general solution, because there is a quest for the general solution of a system is a characterization of set of all its possible solution. Obviously it is different from the particular solution. If you are talking about the particular solution, that depends on the value of a variable, but the general solution is the characterization of set of all its possible solution. Means all solution we can find, and we are now questing for general solution. General solution, what is the definition? General solution of a non-homogeneous system is usually provided by relating it to general solution of associated homogeneous system. This statement finds a notice here. I feel that the general solution of a non-homogeneous system is usually provided by relating it to the general solution of a associated homogeneous system. Now associated homogeneous system, this is important. What is happening? Ax is equal to b, equation number 1, ax is equal to 0, equation number 2. The system of equation is same. Here ax is equal to b, but now here ax is equal to 0. We have supposed b is equal to 0, so this has become homogeneous system. And for the general solution there is a proposition. For now we are skipping the proof here because that would create complexity. So what is the proposition? Let x sub p be a particular solution of 1, means here. So talking about non-homogeneous. If this is solution, x sub p is a solution, is any particular solution of 1, because it is always easy to find a particular solution of non-homogeneous equation. What is the particular situation? We are assigning a particular value to a variable and trying to find the other solution based on that. So this is quite easy to find a particular solution of this ax is equal to b, and x suffix p is the particular solution of 1. Then x is a solution of 1 if and only if x minus xp is a solution of 2. So from here the nature of the general solution that gets derived from here, that x minus xp is a solution of 2. So how to find a solution, general solution of 1? We have to find the solution of 2. First the particular solution of 1, then the solution of 2, and then to add them both to find the solution of 1, which is non-homogeneous. This is the part which is making it non-homogeneous. So let it make clear with some example. Consider the following non-homogeneous system. System is non-homogeneous. Ax is equal to b, and that is quite implicit that this is not homogeneous. A is the form of the matrix, and for the sake of simplicity, the matrix is already in row echelon form. What is row echelon form? We can have another session for that. So we are talking about row echelon form. This is already in row echelon form. You see, so matrix A is defined this way, variable x, we are having we are dealing with 4 variables, x1, x2, x3, x4, and for the part b there is 4, 2. There are, first we have to check whether solution is possible or not. There are no 0 rows, so that the system is guaranteed to have a solution. Had we encountered with 0 rows, some 0 rows there, so we have to compare it with the solution, and if the solution non-zero, then we have to go further. That is a complicated situation. We are not going to mention it here. In this example, we are just trying to demonstrate how to find a solution. First two columns are basic, and how to decide the basic columns we have done in the previous slide, and while the last two are not basic. So first two columns are basic, we can say. First two columns are basic, and while the last two are not basic. We can find a particular solution by setting the non-basic variables to 0. See, what are non-basic variables? Basic variables are part of the solution, and non-basic variables, they are not the part of the solution. So better way to find a solution is put them 0, and we are heading towards a particular solution. We are putting them 0, that they are getting at some result. What we are doing, we are putting x3 and x4 both equal to 0, so we will get some insight about x1 and x2, and after doing so the solution becomes readable, means according to this written statement, and from the matrix we can find that the solution like that 4, 2, 0, 0, means x3 and x4 we have already put them 0, so we are getting x1 and x2 as 4 and 2. This is the particular solution for the non-homogeneous equation. For non-homogeneous equation we have find the particular solution, and now we will head towards the general solution. Let's see. And also solution of the associated homogeneous system is immediate to find. This is immediate to find, means we are going to find the solution of associated homogeneous system is like that x1, x2, and it comes the matrix, because on the left hand side that was positive, it turned to right and it has become negative, and rest of the variable. So there is a dependency. We are heading towards this solution. The solution of the given non-homogeneous system is the set of vector x that satisfy this inequality. Now what is happening? This is sum. This plus is important here. So sum of the particular solution of non-homogeneous and the general solution of the homogeneous. And see, let's try to understand the meaning clear to find the general solution of the system. There is example where another example, matrix A is given like this, and matrix B means solution the right hand part 1, 6, which is making it non-homogeneous. To facilitate things, we are going to transform the system into equivalent one in reduced low echelon form. We can see reduced row echelon form. Echelon form is a different topic in the chapter, when we have to reduce any matrix in the echelon form where row operations are allowed, and this form becomes quite clear, and solution are same. Solution are not going to be altered whenever we are doing any manipulation with the matrix. Not to say manipulation means just like operation with the matrix, means adding or subtracting the multiple of row with any other row. This is not going to alter the solution. So we are going in echelon form. This is echelon form, and variables are here, right hand side is here. The external solution is guaranteed by the fact that there are no 0 rows. No 0 rows means guarantee of the solution. If we think about the 0 rows, then we have to go for the further test. So this is not going to be applicable right here, and what we are doing here, that we can derive we are finding a particular solution, and because it is non-basic, x3 is non-basic. What is basic and non-basic, that has been defined in earlier slides. So this non-basic, so we are just putting it 0. Why are putting it 0? putting it 0 means to find a simple particular solution. Whenever we have to find a particular solution, it is the best way. There are so many solutions, so put it 0 if this is a non-basic, and we get this solution. The general solution of associated homogeneous system, that is important, of all vectors that satisfy x1 x2, this is dependency. This is the general solution of the associated homogeneous system. So what is the nectar of this whole discussion? That we have to find the particular solution of a non-homogeneous equation, because the topic is the solution of a non-homogeneous equation, and whenever we are dealing with non-homogeneous equation, we have to find the particular solution of non-homogeneous equation, because the right hand side of non-homogeneous equation is not equal to 0. So it's quite easy to find a particular solution. We have to find a particular solution of a non-homogeneous equation by assigning non-basic to 0, and then to find the general solution of homogeneous system, associated homogeneous system. What is associated homogeneous system? Associated homogeneous system is that if you make the right hand side 0, and then it becomes homogeneous. So this is associated homogeneous situation. And how to find a general solution of associated homogeneous situation? For suppose I am saying that x1 plus x2 is equal to 0, so we can say that the general solution x1 is equal to minus of x2. This is general solution. We will have an infinite type of a solution. Whatever we assign x1, the same will be assigned to x2 with negative sign. So this is about to get the general solution. So before we proceed to next slide, I would like to remind that the general solution is when our right hand side is 0, general solution is quite easy. So we are getting general solution of homogeneous equation. When a right hand side it is getting some value, then it is quite easy to find a particular solution by assigning particular value to the non-basic variable. And a difference between a basic and a non-basic variable, it has already been defined. So here what are we doing? We are getting here the general solution of associated homogeneous system. The general solution of the given homogeneous system contains all vectors that satisfy x1 x2. This is the sum of the particular solution of non-homogeneous equation and the general solution of the homogeneous equation. In this way we get the general solution of a non-homogeneous equation. I think this is quite enough to clarify the points, and the basic before going to conclude is that whenever we are having a non-homogeneous system, so a non-homogeneous system is quite complex, so that's quite easy to find a particular solution. Particular solution means assign some value to the non-basic variable and find a particular solution. Then take the homogeneous part of the same system and just to try to find the general solution of the homogeneous part. After that just to add them both and get the solution, which is the solution of linear non-homogeneous system.